All right, before we do number 8, I want to point something out, that x squared plus 4, normally we say that that doesn't factor. But if we're willing to use complex numbers, if we're willing to use imaginary numbers, it actually does factor. So we could rewrite this as x squared minus negative 4. Because this now is a difference of squares. So remember, difference of squares will factor. It'll factor into x plus something and x minus something. So to find those things, we just have to take the square root of the first and last term. So the square root of x squared is the x, and I've already written those in there. And then the square root of negative 4 is 2i and negative 2i, okay? So if you're willing to use imaginary numbers, we can actually factor x squared plus 4. And we're going to use that in both of these next problems. So in number 8, they're asking us to write the function as a product of linear factors and then list all of the zeros. So when we do linear factors, that means that we don't want any x squared terms. We want to factor it down to x. So if you have a degree 4, we're going to need 4 factors. Degree 3, we're going to need 3 factors. So our first strategy for this first one, we're going to list all of the possible rational zeros, and then we're going to guess and check until we find one. So our constant term is 9. The rational zeros are plus or minus 1, plus or minus 3, and plus or minus 9. And we would divide that all by the possible rationals or possible factors of the leading coefficient, which is just 1. So we don't have to worry about that. So now we're just going to plug those in. By guess and check, 1 actually works. It works really well. So we're going to put 1 through synthetic division. So that way we can get something a little bit smaller that we can hopefully factor. So our coefficients are 1 x to the 4th, 0x cubed, 8x squared, 0x, and negative 9. So when we do our synthetic division, we multiply and add, we multiply and add, we multiply and add, we multiply and add. So this is going to get us a cubic x cubed plus x squared plus 9x plus 9. And I think this actually will factor by grouping. So we can take out an x squared, which leaves us with x plus 1. We're going to factor out a 9, which leaves us with x plus 1. So we get x squared plus 9 and x plus 1. And this is exactly what I was talking about before we started the problem. We can rewrite this as x squared minus negative 9. And then we can factor it one more step, because now it's a difference of squares. So it's going to be x plus something and x minus something, and we still have that x plus 1. So we take the square root of both of these, and we get x plus 3i, x minus, that's what I meant to put there, 3i. That's just getting worse. Sometimes I try and fix things and it just gets worse. Okay, we have the x plus 1, that was from right up here, and then remember our original one we found was 1, so that's x minus 1. So those are the 4 linear factors of this, which means the zeros. If you set all of those equal to 0, we get negative 3i, positive 3i, negative 1, and 1. All right, we're going to do the same thing in part B. It has a little bit of a weird thing that happens. I'll show you when we get there. So we're going to start by finding a 0. So our possible rational zeros, we're going to look at this guy, plus or minus 1 and plus or minus 5. We have to divide that by the factors of 1, which are just 1, so we don't need to worry about that. And again, we're just going to guess and check till we find one. 1 actually works again, which is really fortunate because those are easy to work with. So we're going to put 1 through synthetic division. All right, so we get multiply and add, multiply and add, and multiply and add. So we started with a cubic. We now have a quadratic, so x squared minus 2x plus 5. And we want to keep factoring this. Unfortunately, it does not factor because there's no numbers that multiply to 5 that are going to add up to negative 2. So there's a little trick, and it's up here in orange. We can complete the square on this. So what we're going to do is x squared minus 2x. We're just going to scoot the 5 over. Remember, when we complete the square, we take this number, we divide it by 2, and we square it. So that's 1. We're going to add 1. And to balance out that adding 1, we have to subtract 1. So we do that. And I'm going to erase this because I'm going to run out of room otherwise. So now we can factor this part. This is x minus 1 squared plus 4. And now I'm going to treat this just like I did the last problem. I'm going to say it's x minus 1 squared minus negative 4. Same thing, but now it's a difference of squares, so I can factor it into a plus and a minus. So we just take the square root of this first term and the square root of the second term. So we get x minus 1 plus 2i and x minus 1 minus 2i. All right, one last step here. I'm going to factor out a negative 1 from these two terms. It's going to be x minus 1 minus 2i. I'm going to factor out a negative from both of those. I get x minus 1 plus 2i. All right, and we had another factor right here, x minus 1. So our factors are here, and our zeros are also listed out there. 1 minus 2i, 1 plus 2i, and positive 1.